Hi, hello students, a very warm welcome to JEE English, a very good evening, Kalikri, Jeremy, hi, good evening, and today we are going to get started with the PYQ session 2 of Electrostatics. So up until now, yesterday you saw the simple ways to answer just from the given question and the options. So now what we'll be dealing with is little bit, we'll be moving the level a little bit higher, and while we move into the session, because this is a PYQ session, our objective is not to keep it, completely just restricted to few techniques that you'll be able to use, but more techniques that you'll be able to use. At the same time, you'll be able to solve this problem. So do not forget to share this video. Since JEE is approaching, you may want to share this with your friends, definitely with your friends on your social media, on your WhatsApp, Facebook, Telegram channel, etc. Do share it. Ask your friends to come on board. It's going to be very interesting. Not only that, guys, students who are aspiring to prepare for JEE but do not have access to very technical, full length and quality lectures for the JEE Main and JEE Advanced preparation, share it with them so that they will get access to this amazing lecture series. And of course, this is not just going to be a concept or problem oriented session, but also along with some tricks and techniques to easily solve the problem. Alright, now let's do a thing. Let's get into this session. It's a PYQ series, guys. So stay focused. Yes, do not forget to share and like this video, and we will get started with a very interesting problem, and then we'll be moving into the depth of the lecture. But before that, let me tell you, stay focused, have a try to notice the way that we are solving the problem. All right, and students, that being said, who do not know me, I am Muralidharan Krishnan. I completed my MS in electrical engineering from one of the top ranking American university. I am also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications in India and abroad, some of the finest technology, and you're learning from the best team, JEE English team. So yes, stay focused, stay tuned, and I also have a track record of winning several national science and tech competitions. Alright, let's get started with the problem, guys. Okay, so this is a 2012 problem. Just don't take it, it's a 2012 problem, but similar problems were asked in your JEE Advanced as well. This is a JEE Mains problem. We'll move into JEE Advanced problems as well, but this is the kind of problems that have been asked before. So 2012 doesn't mean it's a cakewalk. Okay, in fact, recent questions are more cakewalk in electrostatics compared to the earlier one. You can still guess this from the options. Trust me, guys, trust me. What is given to you? In a uniformly charged sphere of total charge Q and radius R, the electric field is plotted as a function of distance from the center. So there is a sphere which has a rate. Let me quickly draw the picture, a very small sample picture. Okay, this is not good enough, I know, but just for now, just assume this is a sphere with radius R and charge Q on it. And what are they asking you to plot? They're asking you to plot electric field as a function of distance. But if you have noticed the question, you are not probably thinking about metal conductor. Why? None of the graphs says it's a metal conductor. So it's a non-conducting or an insulating material. Next. Okay, that is the things that you have to notice from the options. So look at the options. Nowhere the electric field inside, that is inside means from 0 to R. Right? Inside means 0 to R. Right? But anywhere from 0 to R is the electric field 0? No, not in this case. No, not in this case. No, of course not in this case. And no, of course not in this case. In fact, in this case, it says the electric field outside is 0. So what is the concept behind the uniformly charged sphere? Uniformly charged sphere says, good evening students, good evening, a very warm welcome to this amazing channel. Yeah. Uniformly charged sphere says the charge is concentrated. It would act as if the charge is concentrated at the center, be it a non-conducting or be it a conducting thing. Hence, T is wrong because it says R greater than R. What is happening? Electric field is 0. Eliminate this. Next. Of course, it's a uniformly charged sphere with radius r, and it is not going to act like a point charge. So this graph is for point charge. Okay, this says irrespective of the geometry, charge distribution, electric field is proportional to 1 by r square. This is also wrong, isn't it? This is also wrong. Next comes two other things left over in this question. Now we need to work very carefully. We need to really understand among them. If you notice A and C, carefully if you notice A and C, we need to make a decision. Okay, we need to make a decision. But let me tell you something. If you remember, okay, the easiest way to move around this problem in such problems is not to go through the entire derivation. You need to make use of something known as Gauss law. Okay, if you work around Gauss law, it will be super easy. Okay, the multiple ways of doing it, multiple means multiple ways of doing it. If you do it Gauss law, it's like a two-line problem. If you do the traditional derivation, it's going to take longer. So one thing you know is with R, so this is something that we know. Okay, let's move on to the problem. I believe within these two graphs, we need to conclude which one is the correct one, right? Among these two, we need to make the decision. We already concluded B and D are not the correct options. Okay, first of all, eliminate in graph-based questions, eliminate the options that you are not sure about. That would give you the first one, because sometimes graph-based questions are just cakewalk in your exam, students. Graph-based questions are cakewalk. Trust me. They can be the easiest scoring questions given that you understand the method to solve it, how to eliminate the options, and as well as, of course, to how to finally get to this conclusion. Between these two, you can guess it, but if you guess the wrong one, you'll be losing marks. Okay, all right, what did I say? We need to do something around Gauss law. And one more thing you know is, as this is a uniformly charged sphere, okay, there are charges everywhere. I will be erasing this, guys, because this is not very convenient for our calculation. So there are charges everywhere. If charges are distributed uniformly inside, okay, if I take a Gaussian surface, if I take a Gaussian surface with symmetrical charge distribution, what happens, students? This would enclose more charge. Okay, let's call this R. This R is less than R. R is less than what? R, which R? Radius R. R is less than radius R. Now arises the question, if R is less than R, as R increases, what increases? Charge enclosed increases, which means electric field should increase because electric flux is proportional to charge enclosed by epsilon naught. In this case, of course, there would be an epsilon. But anyway, now that being said, you know, this should also increase. Now comes the next thing. If flux is increasing, electric field should also be increasing. Because one, your surface area is increasing, but at the same time electric field should be increasing. If you notice it, you will get this point throughout this thing. So as R increases, electric field should increase. Okay, this is the first conclusion that you have got. So among this, any one of them can be true. That is how I said that, because with R is increasing, you know, like flux is increasing. But if you notice this one, okay, if you notice this one, this is a non-linear function of R. And what about this? This is going to be a linear function of R. Okay, this is like y is equal to x graph, right? This is going to be a linear function of R. Easy. So now you know these two things, and now you need to carefully work around the problem. As I told you, the easiest way would be to move around charge enclosed. You understood, as R increases, electric field increases. This is the first conclusion that we have, and you need to definitely understand this. Now let's see whether how to derive the equation, whether it's a linear or non-linear. It's a two-step problem, guys. If you understood the concept, it's literally a two-step problem, and that is why we have this as the starter question. Let's say I've taken like a Gaussian surface. This Gaussian surface, okay, it's a uniform charge density. I'm going to take rho. So this is a Gaussian surface, and this Gaussian surface is going to enclose some charge. How much is that charge proportional to? It's going to be rho into volume of the sphere. Which sphere? Volume of the Gaussian sphere. Right? And how much is that? Rho into 4 by 3. In this case, we are assessing at a distance r as a function of r, where r is less than r. Okay, we are doing this for r less than r. R greater than r, we know it's like a point charge. It should be like decreasing non-linearly with respect to 1 by r square. Alright. So this is going to be how much? 4 by 3 pi r cube. Isn't it easy? Easy. Alright. Now we have this. Now we need to do something known as, we need to assess electric field. Okay. Electric field exiting. Okay, it's all exiting in radial directions, if you can imagine this. But anyway, we discussed this during our normal session. You know, it's all electric field, electric field, electric field. Given that it's positive charge, it's exiting. Given that it's negative charge, it's entering. Okay. Anyway, assuming this to be a positive charge, so this is the flux. Okay. How much is flux? Flux is, okay, let's assume this dielectric of this dielectric material to be 1. So this would be like Q enclosed by epsilon naught is equal to, what is flux? Electric field into area. This is electric flux from Gauss law equation or Gauss equation. This is going to be electric field into area. Easy, simple. Next comes the question, how to solve this question. Right. Okay, we need to do work around the area. Area is how much? Area of this is how much? Of this thing, of this enclosed surface? 4 pi r square. And of course, you know the value of rho. I'm not writing down the value of rho because anyway it's a constant. At the end of the day, in the question, you don't need to know what is the value of the rho. If you are given uniform charge distribution, you need to find it out as a function of r. You need to be only worried about that smaller, not that larger. Okay, but anyway, your rho is going to be q divided by 4 by 3 pi r cube, capital R cube. Okay, capital R cube. Easy. Now comes the question, like how to calculate this. So electric field is what we have to calculate. Function of electric field is what you have to calculate. Okay, I'm removing this the sign, but we are only worried about the function. We can take care of the vector later. And how much is this? 4 pi r square, as you saw over here. This is the surface area of this Gaussian surface, isn't it, guys? That's it, students. Done. So this is rho into 4 by 3 pi r cube. Simple, isn't it? Simple. Divided by epsilon naught. What is this? This is this charge enclosed. Okay, from here you'll be getting. Trust me, it's a simple problem. You can cancel out 4 pi, you can cancel out r square, r. So it should be a non-linear or a linear function. It should be a linear function. Okay, so there you go. For r less than r, given that it has a uniform charge density, how much it should be? Electric field should be rho into r divided by 3 epsilon. You can have a look at the problem later on. Okay, the way that it has been okay, there would be of course be an r cap attached to it, but that is a different thing. Our function is electric field vector. Is it proportional to radius to the power square or something, or is it proportional to radius to the power 1? It is proportional to radius to the power 1. So it's a linear function. Electric field is a linear function. Easy. So yes, answer should have been then C. Okay, answer should have been then C. You know, this is wrong, this is wrong, this is wrong, because it's not a linear function. This is a linear function. Answer should be. Alright, let's move on to this next problem. But before that, let me Yeah, okay, answer should be C. Anyway, so yeah, students, we are going to get into more PYQ problems. Do not forget to share this video. Do not forget to like this video. Definitely do click on that subscribe button and bell notification. And students, you know what? If you don't have a Telegram app yet, just do download it from your Google Play Store and App Store and click on to this link which is available in the description box below. Stay tuned. We are going to get into more and more interesting problems and the way to solve around them. More importantly, how do you analyze for from your JEE Mains and JEE Advanced perspective? That is also very important. Yes. So do remember, yeah, do download our Telegram, do download the Telegram app and click on to the link that is available in the description box below. Once you get onto a channel, you will get before time updates on every class that is being conducted by JEE English lecturers, either on Unacademy Learning app or on your JEE English YouTube channel. But yes, do just type in JEE English even if you already have the Telegram app. And that being said, students, you know what, if you don't have a Telegram app yet, do download it. But if you don't have an Unacademy Learning app yet, do download that as well. Why do you want to download the Unacademy Learning app? First of all, it's like an app which has like a lot of free of cost features for your JEE Mains and JEE Advanced preparation. So all you need to do is type in Unacademy in your Google Play Store and download it. Okay, and not only that, we are impacting near about 7 million lives and you are one among them. So do install it and make sure you are learning for your JEE Mains and JEE Advanced from anywhere. So what do you get with Unacademy Learning app? One, definitely you get many free of cost sessions. I keep conducting A to Z session on Unacademy Learning app. So you can check out the session. We have completed already a lot of lectures around current electricity, capacitors, and many topics are on Unacademy Learning app. So these A to Z lectures are something that you can check out on units and dimensions, etc. So yeah, for both 2020 aspirants, 2020 aspirants, this is a very important part for you. So do download Unacademy Learning app and click on that follow button. You'll be able to follow me and get live updates. So yes, if you download Unacademy Learning app, you'll get live updates from the best educators and also your favorite educators. And guys, not only that, that is one thing. Of course, you'll be getting live updates, etc. on the classes conducted by your favorite educators. But do remember one thing, if you download an Unacademy Learning app, you can attend free of cost quizzes every Tuesday and Thursday, national level free of cost quizzes. And guys, one more important thing, you can attend also Unacademy Combat and you can attend this free of cost special classes from anywhere. And if you have opted for Unacademy subscription, you can attend these structured programs and test series from anywhere. Yes, that being said, what is that thing that you are looking for in an Unacademy subscription? Do we have that? Yes, we do have that. First of all, what is an Unacademy subscription? Unacademy subscription is the best in class program for your JEE Mains and JEE Advanced preparation. What do I mean by the best in class program? It's going to be a structured program with the best educators across the nation, where you do not have to go through the hassle of planning it all yourself. Everything has been pre-planned on Unacademy subscription platform in terms of your JEE preparation. And every program comes with, a doubt clearing session. Every fourth session is going to be a doubt clearing session. Every course, individual course will come with lots and lots of, not just doubt clearing sessions, but also with quizzes and mega quizzes. That way you're able to get the completeness on your preparation. One, with doubt clearing session, you'll be able to maintain the completeness. With quizzes, you'll be able to assess how you're doing all along your journey. But that is for programs and individual things. We also have national level test series, which is very important for your JEE Mains and JEE Advanced preparation on Unacademy subscription platform. And guys, not only that, the platform is fun, it's going to be a very interactive and attractive platform where you will enjoy this learning, where you will enjoy this journey. Hi for education. Hi students. Good evening. And how do you avail this amazing program with best educators across the nation in the form of best program? All you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as the code, and let me tell you, we have programs for both JEE Mains and JEE Advanced, and hit on this get subscription button. What do we have more? We have unlimited access throughout that period. You can access as many programs as you want. Yes, you can access as many many programs as you want. You can enroll to as many batches as you want. Enrollment is not a restriction. You can enroll to as many JEE programs as you want on Unacademy subscription platform. And guys, if you are looking for a 24-month thing, we do have it at a price of 2,100, less than 70 rupees a day is what you have to pay for 24-month subscription. So what is this 24-month subscription? 24-month subscription is typically meant for 8th class, 9th class, 10th class and 11th class students. So why do we say that this is meant for these students? Because it's a 2-year long journey. If you prepare comfortably, it's pretty easy to crack JEE Mains and JEE Advanced. And guys, yes, this all comes at a price of less than 70 rupees a day. It's not even 70 rupees a day, 2,100 per month. Some months do have 31 days. And guys, do apply Murali Live code to get the best features of paying parts, which is our in-house feature. And we also have access to no cost EMI. No cost EMI is something where you don't have to pay any interest on your easy monthly installments. So these two payment options will remove that burden and will not let you go through that hassle of paying all the fiat ones, and you can split your payments into multiple parts. We do also have debit card, credit card and UPI based payment options. And guys, if you're a dropper or long term, a 12-month program is meant for you. Why do we say that a 12-month program is meant for you? Because we have dedicated droppers batch for droppers and long-term students. Even if you're in class 12, you can still start and do it. Given that you attend the right kind of classes, you enroll to the right kind of programs, we have individual programs and you also understand strategy, right? We have individual programs where you'll be able to maintain completeness, and then we also have full-fledged droppers batch going on, and more importantly, we have national level test series going on, which is the key for 2021 aspirants or 12th class students or droppers, etc. So this all comes at a price of less than 2,888 after applying Murali Live code. So do apply Murali Live code and avail the best discount on your subscription purchase. Yes, students, this is about plus subscription, but we have something little more than plus subscription, that is known as iconic. Not little more than, but a very key thing is added in this iconic subscription. So what do you get in the iconic subscription? You will get everything that you get on plus subscription, but bit importantly, like NITians and IITians who have previously have gone through this journey and who can guide you through this journey with their personal touch, with their personal mentoring, with the also kind of the guidelines, like expert guidelines and on what to do, what not to do during a JEE Mains and JEE Advanced preparation. And guys, we will also keep conducting workshops on iconic subscription, and this all comes at a price of 58,500 if you go for a 12-month subscription. If you go for a 24-month subscription, this is going to cost you how much? 90,000 only. 90,000 is what it is going to cost you for a 24-month subscription. And do not forget to apply Murali Live code to avail the best discount on your subscription purchases. Any of your subscription purchases, be it plus, be it iconic, or be in any of the programs, you can apply them. And students, our team, JEE English team, is on iconic subscription. Now you can take your JEE preparation to next level with our personal coaching in English, with our IIT JEE workshops, expert guidelines, study planners and test analysis, and more on iconic subscription with our JEE English team. We have the best in class team, guys. We have IITians and IITians and head of coaching institutes, head of departments on our channel. And guys, let me tell you something more interesting about us. That not only that, we do also have today at 9:30 p.m. we have an Ask Us Anything session. So do remember, we are an iconic subscription team with IITians and IITians and head of coaching institutes. So definitely do attend this session. It's again a free of cost session only. There's nothing, it's like a free of cost iconic session. You would love to do this on our channel because we'll be able to guide you through the strategies that you need to do, because we also have different kind of faculties or different kind of graduates, you can say, have gone through different kind of journeys. So we will be able to share with you our experience in this journey if you come and ask us anything. Okay, if you come and ask us anything, given that you come and ask us anything, we'll be able to do that today at 9:30 p.m. Any strategy, it can be anything, it can be like how to, prepare in this next 3 months, or should you be worried about the given timeline? Would it be postponed anymore? What do you think, etc.? So postponed and etc. Like no one can predict it, but you can, I would say, more fruitfully, you should be coming up with questions which are going to help you in your JEE Mains and JEE Advanced preparation. It can be anything, it can be literally be anything, like where you're asking how to take down the notes. For an example, as far as physics is concerned, you should be taking down notes, you should be practicing it, but at the end of the day, it should be all along with you. You should be diving deep into the concepts. So the same goes for mathematics. But let's say it comes to chemistry, how do you deal with it? So we have Rahul sir on the team, who has been heading the chemistry department of Bansal classes, and he would be able to give you those ideas and those tips in the given short time. And of course, if you're looking for some tips like how to prepare in the last moment of your exams around physics, and if you're looking for some expert guidelines, we have 2 physics faculties on our team. One would be like Rohit sir, and the other would be myself. Yes, we are also rank holders in your JEE Advanced and JEE Mains. And of course, when it comes to apps, we have our Abhinav sir, who would be taking you throughout this journey, given that you would be taking you throughout this journey with this useful tips and etc. on how to work around math, etc. Given that you come at tonight to 9:30 and ask your questions. Do remember to share this session as well with your friends. So let's get into today's session. And before that, let me tell you what we know is a drop, but what we don't know is an ocean. Be sure about the drop so much that you're able to excel in this pursuits, guys. So keep your dream alive. Your dream should be alive. Your dream is the thing that is going to drive you. That is going to be the key driver. You should be like, I want to get into IITs and NITs. You should be so adamant about it that it should linger in your dreams, but not so adamant about it that it is spoiling your dreams. So yes, make sure you are ready for this game plan, etc. You can come and ask us anything today on how to perfect this drop in this ocean that you don't know. But let me tell you, your syllabus is not an ocean. It's a drop of that ocean. You need to be thorough with only few of those drop of those oceans to make it happen. And if you do not have confidence in yourself, no one else can help you, guys. So do have the confidence. You should believe in yourself more than anyone. All right, let's get into a very interesting question, guys. Of 2016 JEE Mains. Of course, we have already discussed the previous questions of many other years. But okay, when it comes to electrostatics, what is the significance of electrostatics in your JEE Mains? Sometimes 2 questions, sometimes 1 question, sometimes come with a combination, it can be 3 questions as well. So there is no definite number of questions that would be asked from electrostatics. And especially the thing I like about electrostatics when it comes to JEE Mains is it's easy. Compared to the rest of the topics, compared to JEE Advanced, JEE Mains, PYQs, you would notice it to be easy given that you understand the concept and also the technique to solve the exam. Okay, let's get into this question then. This is a very, very interesting question, guys. Very interesting question, right? So given to you is a region between 2 concentric shells of radii A and radii B, and as a volume charge density rho is equal to AR, where A is the constant, R is the distance from the center, and at the center of the spheres is placed as a charge Q. The value of A such that electric field in the region between the spheres will be constant. Students, okay, let me tell you, first of all, you need to understand the question carefully. So I would definitely recommend that before I get started on to it, you have a look at the question, you carefully read the question, because I don't think is there any shortcut to work around this. Let me quickly think about it. I don't think there is a shortcut. Is there a shortcut? Maybe there is a shortcut. Let me think about this. Okay, let's see. At the end of the question, we'll be concluding with some new concept and shortcut. I think there is a shortcut, but anyway, first of all, let's try to understand this concept, because this is a critical concept which we haven't discussed in the class as well. So we need to discuss this concept. What happens when a charge is placed at the center of two concentric spheres? Think about it carefully. What is given in the question? Try to first of all, okay, first thing that you should be doing today, as we are attending this PYQ session, should be writing down your, like not assumptions, but the question appropriately. What do I mean by you should be writing down the question appropriately? You should be first of all be able to understand. Okay, you need to understand it aptly in terms of your figures. What are figures? When you're drawing it on the figure, and also next is also guessing the concepts, or you should be sure about the concept, but I'm saying this is guessing the concepts. So these two things you should have done it the moment you read the question. Take your time, try to do this both. If you're not getting it, it's well and good. Do understand that if you're not getting it, you have to learn from your mistakes and you have to improve upon it. Okay, anyway, I haven't asked you for the answers. You can still comment the answers if you know them and if you calculated them, but I would be like more interested if you're commenting on the way you understood it or the concepts. Alright, comment at the moment you see, not after solving the question, guys. Okay, alright, now let's get into this concept. Okay, what has been told to you is, okay, I'm not going to give this thing a definite sign, but like there is some charges distributed between which region? Between this region. If you understood this, good, amazing. And let me tell you one more thing. This picture was not given. This is something that I got for you. If you understood it from the picture, don't do that. These pictures, I get it for you, for your understanding, but these pictures are not given. Okay. So you should be, I don't say that during our conceptual sessions or regular sessions, but PYQ sessions, students, these pictures were not given. So you should be able to intuit what has been exactly be given. This will come with practice. Practice is the key. Alright, so there is some charge that has been distributed like this. Between which and which part? Between this part, the charge has been. Okay, between this part, the charge has been distributed. And I think, in the answer B is not required. It should be between A and C, A and D. How did I come to that conclusion? I'll come to that part. I'll take you step by step. The moment I got into the question, I sort of understood B and C should not be the answer because B should not be involved in it because it is constant. Okay. It is constant. Let me read the question again for you. How did I say this? I hope you have noted down, understand and guessing the concept part. So see, it says between the two concentric spheres of radii A and B respectively, they have a volumetric charge density of how much? Rho is equal to A into R. Now given that A is a constant, your charge density inside should be constant. Okay, charge density inside between those metallic spheres should be constant. Between the shells should be constant. When is that possible? That is only possible if at all you're calculating or you're deriving an equation that is only dependent upon A and an R. A and an R. Right? I'm drawing on the figure, but how do you mathematically intuit the answer or make a decision between? Anyway, I don't think between A and D, I would be able to guess it. If you have a shortcut for that, that would be amazing. But it needs to be dependent upon A and R. It cannot be dependent upon B. You'll get that thing. Okay, it is going to go from some A at this point to R at this point. It cannot be dependent upon A and B. Easy. Some ways of concluding it. I don't know what is the answer. Let's get into it because I am also solving it all along with you. But probably, if you understood the concept, it's a simple concept, the same concept that we have begun with. It's going to be about Gaussian law. Okay, between them there is some charge density rho. This charge density rho is not a uniform charge density like the earlier one, if you understood that point. It's dependent upon what? Radial distance from the center. Radial distance from the center. Right? Simple. As simple as that. Right? Now let's get into this question. Okay, what I'm doing is drawing a Gaussian surface. But while drawing a Gaussian surface, you need to be very cautious, not about the way it is drawn, but about what are the charges enclosed in this situation. What are the charges enclosed in this situation? If you have understood something around this point, the charges enclosed are dependent upon the radial distance. It's dependent upon the radial distance. Okay, if rho is dependent upon radial distance, what do we need to do? We need to integrate it for each shell. But let me get to this point. So we need to calculate something known as charge enclosed. Let's understand this carefully. One and the primary thing. What is there around this? There is something known as a Q charge around this at the center of this piece. So your charge enclosed, you must be very careful to include this Q in it. Next, what is it? Next, it should have this thing. Okay, this thing where some charge is distributed. This point. Whatever is this, okay, I'm just showing you with the symbol. It's not necessarily positive or negative. It can be any one among them. All right. So now I need to calculate this part of it. Okay, let me just use a different color, like this thing. How much is this going to be? I cannot directly state anything. Okay, if I have to calculate it from A to R, I cannot directly state anything. It would be an integral of something. Okay, integral for what? Each shell. Okay, this is what this integral is for. What? This is for each shell, and this shell extends from where to where? A to R. And how do you calculate this? You'll be multiplying the charge density with the shells assumed. What is that? That is known as like an dV, or that you can say differential volume, and you'll be getting. But rho, as you know, is dependent upon R. You need to be very, very careful around this calculation. High current, high. Current, yeah, high current. All right. So do not miss out this. Do not miss out the rho part. Rest is easy. Now you're wondering what needs to be done if the electric field is constant. Okay, they have told you this electric field is constant. First of all, you understood the moment I wrote this, we are going to work around something known as Gauss law. Okay, I'm not integrating it yet. Let's have a look at it, how to do this. So this is something around Gauss law. Okay. So this is only valid for R to A. If I had integrated this, let me ask you a question. If I had integrated this and calculated, the final result, and just kept it and said that, the electric field, if I calculate the electric field between that area, and said that, guys, this is it. All we need to do is if I differentiate this equation, it's a constant, hence this should be 0. That is when it would be possible. Would that make sense? Absolutely. Right? Absolutely. That would also be. Alright, let's first of all calculate what is the electric field in this case. I'll do that. Okay, I'll do that. What is Gauss law? Don't worry about it. So students, one of the students have this query, but if you remember what is Gauss law, if I draw a surface like this, we discussed in the beginning also, guys. So this says, Gauss law says, given that it is a uniform charge distribution, symmetrical charge distribution, it says that some charge enclosed in it. Okay, that is it. It says some charge enclosed in it. Inside this Gaussian surface, we call this, so it's a 3D surface. Try to imagine it as a ball, and that some small imaginary ball is drawn between these spheres. Then there would be some charge enclosed in that imaginary, inside that imaginary sphere, and this would be like having some surface area as well. What this sphere would be having a surface area. If I'm going to talk about it from the center, it's at a distance r. What is the, let me quickly recap this point, but I think we have just discussed it in the beginning. What is the surface area? Surface area is going to be 4 pi r square, given that this is radius r. Okay, now let's move on to this. Okay, that is all Gauss. Okay, Gauss law doesn't say this. This is surface area I've defined. So through the surface area, there will be exiting some flux, given that it's a net positive charge. There will be some flux exiting this thing. Okay. What is flux? Flux is nothing but the field lines or the field intensity multiplied by area. So there will be some field lines exiting that, which is nothing but called as flux. What is flux? Flux is denoted by phi, and phi E is equal to what? Electric field into area, which is nothing but the intensity of that electric field exiting that area. Okay, so this is easy. Now comes the next part. Okay, now this is proportional to Q enclosed divided by epsilon naught. Okay, this is proportional to Q enclosed by epsilon. Easy. This is Gauss law, guys. If you do not know Gauss law up until now, this is Gauss law. That is it. Don't ask me what is the explanation behind this, etc. There was a session in which we derived partially this thing, but that is none of our business. Gauss said this works as long as it's not as long as it's a symmetrical charge distribution. It does not work as long as it's not a symmetrical charge distribution. That is it, guys. Clear? We are going to work around this only. We are not going to do anything new in this question. Okay, this must be clear in your mind. Okay, I know most of you know this, but for students who don't know this, who are attending the session for the first time, this is just for you. Okay, we need to integrate around this. This integration is clear, I believe. This is rho is equal to A into R. So I'm going to integrate this equation, take and integrate this equation and see how this value comes out to be. Okay. Let me integrate it for the Q. What did we have? Q total inside any surface would have two components in them, as I explained you. One would be this Q. It's a simple question, students. Okay, how did I guess it should be A? I said that there is no involvement of B if I'm moving from A to some distance R. So in your final answer, there cannot be B. And I knew the concept. It was like Gauss law. Okay. Very good, guys. Amazing. All right. So one charge is this Q. Okay, this time I'm writing it down in the same color, but earlier I wrote it down, if you remember. And this as a rho, between which and which distance? This distance. Okay, I could have shaded this. Okay, let me shade. If someone is not understanding it, they will understand. I know students who are understanding it. It's good. But students, I believe this should be clear. You guys are smart and you should be able to get it. Okay, I am doing a mistake over here. What is it? I should be adding it up. One is Q charge and other is some rho into, what is this? What is this thing? How are we moving? Elemental shell volume 4 pi r square dr, and this varies from A to R, not 0 to R, A to R. Okay, so if I do this, how did we get this small shells? I believe you know this thing. If not, do check out any of the lectures around how to derive for a given varying charge density. It's a little advanced question according to me. It's not a very easy question, but given that you understand the concept, it would be some manipulations. Of course, it would be easy. Okay. All right, A is constant. A is given to us as constant. Now, if I am going to calculate this equation, okay, if someone had a problem around this, think about it. From integrating from year to year, it should be like thin shells, like thin hollow spheres or shells, which has to be integrated from A to R. Okay, many of you, this must be clear, I believe. Okay, we are attending PYQ session, this must be clear. Okay, let's integrate this thing. This what? This is like A into R, 4 pi r square dr. How much should be over here? So this should be like, let me do a thing. Do we even need to calculate this? That's what I'm thinking. Yeah, we need to calculate this. There's no way out of this. Okay, fine. There's no other way out of it. Let's do it. Okay. So Q total, if I integrate this thing, one would be Q, which is a constant value which is present, and the other one would be like A would be outside, 4 pi A would be outside, of course, and then what do we have? 4 pi A would be outside. And then we have R cube dr from where to where? From R to A. Okay, so this would be like Q plus of 4 by 4. Is that what we are getting? 4 by 4. Sorry. Yeah. Just a moment, guys. I'm just having a look at the system. Okay. Right. So varying thing. So yeah, this would be like, I can't write it down over here. Let's carry on this to the next page. This should be like Q, like I'm just writing down quickly what it should have been. 4 by 4, so it will be like a pi. 4 by A into, okay, you need not necessarily understand what is being written over here. You just need to understand what we are doing. This is what we have done. We have done the integration. Okay, let me carry this on to the next page. It will be more clear. Okay. All right, let's carry on. So the Q total would come out to be something like this, the same thing that what we have written earlier, Q plus of 4 pi into 4 pi A into A is a constant, and integration of R cube dr is going to be R to the power 4 by 4, and this would go from A to R. That's important. Okay, that is it. End of the story, I guess. So 4 and 4 would get cancelled out, and this would be from A to R to A. So you would get Q total, and the next thing you know is going to be Gauss law, guys. Gauss law is the next thing, is equal to pi A R to the power 4, which should be written as A to A to the power 4 minus, sorry, R to the power 4. I'm really sorry. Okay, R to the power 4 minus A to the power 4. Alright, that is it. Now we have an interesting thing known as, what is this? Charge enclosed. Charge enclosed, if you remember this. Everything is okay, everything is correct. If you believe, if you understood, everything is easy, and if you believe everything is easy, definitely. And yes, okay. Now let's move on to the next thing. I'm going to write down the Gauss law, guys. You need to understand this point. E into area. What is area in the situation? How much flux is going to exit from which area? Like flux is going to exit from which area? This area, which is going to be for a given distance r, is going to be 4 pi r square. It appears lengthy, but if you do it, if you understood the concept, it's a short question. Okay, is equal to what? Charge enclosed by like epsilon naught. Charge enclosed by epsilon naught. Okay. And this is flux. This is what Gauss law says. Gauss law says these two things. Actually, this is the expression of Gauss law, if you remember. But this is nothing but this only. Okay. How much is charge enclosed in this case? Q plus of pi A. Okay. The moment I arrived here, I almost understood it should be 2. But anyway, let's solve this question. It should be R to the power 4 divided by A to the power 4. So now what should be your A such that this term remains constant? Okay. One of the ways to go about it is you manipulate around this equation, you play around this equation, you come up with something, and you say, okay, this works. The other one is the traditional way is calculating the field and saying that dE by dr is constant, so it should be 0. It should be 0, isn't it? So you could have said that, you know, charge per unit area should have been constant in very simpler terms. Okay, let's move on and solve this, guys. All right, so yes, so let's move on. The next thing what I'm going to do is I'm going to work on 2 equations. Let me show you that before we move on, because you don't want to be confused while we start solving it. So we have this over here and this over here. Okay, so now what we need to do is we need to work around these 2 equations, and we'll be getting the value of what? Electric field. So electric flux, what we need is electric field, which is going to be Q by R square minus of plus of A into pi divided by A to the power what it should be, A to the power 4. Okay, R to the power 4 divided by R square, which is going to be how much? R square. Which is going to be R square minus A to the power 4 by R. This is correct? Yeah. Alright. So one thing we know over here is this would be like Q plus of, not 2, I guess it's just 1. So Q minus A pi. Can I write down something like this? A pi A to the power 4 is equal to divided by R to the power R square plus of A pi R square equal to E. It just rearrange the terms. This has been brought to this side and it has been done. Okay. Now the question arises, how do you work around these kind of problems? 1 dE by dr is equal to 0. Okay. The simplest way would be to say dE by dr is equal to 0, hence this should be 0. Okay, there should be a 4 pi. Okay, yeah, there should be 4 pi over here. Yeah, I think we have missed the 4 pi. Okay, we have 4 pi. Okay. Another one is let's do that way. Let's differentiate it with respect to r and say this is 0, and it should be independent of r, which means this term has to be, do a thing. Let us do a thing, equate it to a and b and also find out. And the way would be a then you get the value of r. You need to substitute the value of r in this, and then you'll get the final value of a. But can't we say that a into pi into r 0? Yeah. Alright. Solve this problem. So even without integration, we would have done it. We have integrated this. Into r 4 pi r square dr. Correct. The moment I'm just checking out whether it can be done without there could have been a simpler form of. Okay. So but the simpler form of differentiation as an issue. Okay, all right. Okay, so let's do this. Let's I don't think there is a simpler form of this differentiation. You know that electric field is independent of R. That what is given to you? It's independent of R or A. The region between the electric field would be constant. The region between electric field is constant. What about the potential difference? Potential difference should be 0, right? dE by dr is equal to the potential difference. Potential difference should be 0, or dE by dr is equal to 0 is the same thing. Okay, it does not vary with R. This is something that we can see. All right, so this gives us something like Q minus of A pi A to the power 4 divided by 1 minus 1 by R cube. Okay, minus 2 by R cube. Okay, 2 plus of A pi 2R divided by 4 pi is equal to constant with respect to R. If you differentiate it with respect to R, it should be 0. So what should be the value of A such that this term becomes independent of we know Q is constant, R. So you could have said one more thing. Q enclosed by R square period charge. Different places, even different fluxes are not exiting. Area is changing, so flux is exiting. I think this is all correct. Just verifying this not wrong anywhere. Just a moment. Just a moment. This is Q. This is Q. That is margin. And yes. Pi A R to the power 4 minus 4. That is all fine. There is some issue in the question, maybe. Approach. Okay, R square. This should be independent of So if this has to be independent of R, this is also 4. So differentiated electric field with respect to R, and term would be there, this term would be there, to be like Q is equal to 2 pi A, sorry, A is equal to, substitute 2 pi A for feasible solution. Alright, let's quickly check it out. This we have arrived here. 4 by 4 by I don't think any solution is feasible at this point. Electric field with respect to R is constant. A. So that would give me R cube in this place. If I substitute this to be A, R is equal to A, this should still be constant. And okay, that's another way of approaching this problem. So the other way would be I'm going to substitute R is equal to A. that is not the apt way of going about it. R is equal to B, R is equal to A should be constant. If I say that which is the term that is going to change, what's going to change? All right. Okay guys, let's do this. Let's go by the approach that we have gone. There's no shortcut, I believe, in this question. So anyway, I think it should be only dependent upon A, and probably something is going wrong in this question. Associated with respect to R, they have different 4. So D should be 0. Yes. Like just a moment. Differentiated even before calculating this net flux. Not. This is going to be the integration of the whole thing, isn't it? Volume charge density is changing. So all right guys, let's conclude this question. Okay, I think something going wrong in this question, maybe not. Has to be constant. These two terms have to be equal, should be independent of R. That is only possible in feasible solution. So the other possibility is A is something like A to the power, but A is a constant, right? All this 4 pi cancels out. Okay, let's write it down and see if we get a feasible solution around this. Q minus A pi A to the power 4 divided by, so 4 pi can be taken out, so don't worry about the 4 pi. So it will be R cube. So this will be like R cube, and there will be a minus 2 which has to be carried, and differentiating this, I would get something R square in this side. In this side there would be like an A pi on, and what do I have? R square by R square by, okay, that's it, right? R square by that 4 pi. Okay, that's not R square, that is just 2R. Let me check out the solution later on, come back. I think there is some issue in the question as such. This has to be independent. So another way of doing it, what if I differentiated itself? Still I do not. Do I? D is constant with respect to, I can say DE 8 by R is equal to, there would be like an R square. R electric field has to be constant inside. Okay, but this term is dependent upon R. This term and this term is dependent. Oh, of course, this also dependent upon R. We have nowhere. Okay, I think we made a small mistake. It should be A by R. I think it should have been A by R. Else A into R, it's not at all possible. Okay, mathematically it's not feasible. There is a small issue in the question. Okay, it should have been A by R. Now this will work out. Let's see. Okay, okay guys, correct it. Rho should have been A by R. I'm really sorry, but rho should have been A by R. Now I think there was an issue. I think it might have been my mistake that I have to take down the wrong thing. It should have been A by R. This would work. Okay, all right, that's my mistake, absolutely my mistake. Just to change this, so this should have been also A by R. Okay, This should have been also A by R, because you know why? Because if it was A into R, this is not at all feasible, because charge density is increasing. What you have inside is like with area, what you have inside is a constant charge Q. That would never be feasible. So the question would have had A by R. I think I might have mistakenly wrote it down as A into R, or maybe it was given as A into R, but it should have been A by R. I think I might have made the mistake of noting it down as A into R. A into R is not at all possible. It should have been A by R. So yeah, quickly correcting this. This is a simple question. You notice this. So my mistake, guys. My mistake. Really sorry about it. So anyway, these kind of things can happen in your exam. You should not be wasting your time. That moment you should be noticing something is going on, you should be skipping the question and moving on. Maybe your paper just add, you know, like A into R. So yeah, so it's a simple question. I didn't okay, not at all problem here. So yeah, let's correct all of it. So this would not be R to the power 4. This would be, let me quickly redo this. Alright, I hope you understood up until here. It's rho into A something. Alright, this should have been A by R. Okay, this is also fine, I guess. In this place, what did you get from this equation? Let me quickly go take you through this. It should be R dr, because one R gets cancelled out over here. So it will be like 4 pi A R dr. 4 pi A R dr. How much do you get this to be? R square minus of A square. So this varies from R to A to R. So this should be like R square instead of R to the power 4. It should have been by 2, of course. And this 2 and this 2 would get cancelled. You would have a 2. So you should have 2 pi in the answer, students. Okay, my mistake. You should have had 2 pi in the answer. So I thought it was A by R. That's the reason we were not arriving to any conclusion. So it should be like 2 pi into A, and this should be like A square and A square. Okay, R square minus A square. So yeah, that is simple, right? I'm just replacing the same thing. I'll write down this equation again for you. Okay, because I think it has been a little confused in terms of noting down the question, or the question where I picked up from had gone wrong. So yeah, so this is going to be what? So this is, I'm writing down the Gauss law. This I hope you understood. I just integrated this term. I got R square by 2. This should be like 2 pi R square, and this should be from A to R, and that would be giving you 2 pi R square minus A square. And this is Q enclosed. It would include two parts. One part, that is this charge density in between this R and A, and one is that Q. So the thing you have to do is Q plus of 2 pi R square, 2 pi A R square minus A square is equal to divided, because how I understood it, I'll tell you. I'll exactly give you the reason why it should have been A by R. It should not be A into R. A into R, you understood, right? Of course, your charge density will keep on increasing, and it can never remain constant. Once you work around this term, you will get it to be that. This is just a mathematical conclusion that I did in a short moment. So this should be R square minus A square, 2 pi A into R square minus A square. Divided by what? Epsilon naught. I'm really sorry, students. Correct it. It's A by R. Now you will get the answer. Okay, quickly, guys. Let's do a thing. Let's redo this entire page. I hope up until here it's clear. Else do work around it once more by yourself, all by yourself. It's a simple question. So yeah, take down that R square on the denominator and find out electric field and differentiate it with respect to R, and you will get the answer. Alright, I'm going to do the same thing. So it's E into 4 pi R square, which is the two things that I'm going to manipulate. One is going to be E into 4 pi R square, and the other is 2 pi A into R square minus A square divided by epsilon naught. Alright, so yes guys, it's a simple question. 2 pi A R square minus A square. Alright, that's what we have. Plus of Q. Where is that Q? Q is missing in this thing. Let me add that Q. That should have been Q, right? Enclosed includes two parts. Alright. Easy? Easy, guys. I told you since the beginning it would be easy. But I think we messed up the question. Hence, it had been lengthier. My apologies from the paper that I picked up, it didn't have the right kind of question. All right, so now this is totally feasible. Now let me get to this point. Let me write out the entire thing again. So two components of charge enclosed. This is going to be like the Q1 and this is going to the Q. What is Q1? Q1 is between it. Okay. Now that being said, this is what electric field into area, surface area, which is going to be 4 pi r square. Just take it on the denominator. I'll be making use of the same color. Electric field value, how much does it come out to be? That's what I was thinking, you know, this JEE mains question should not be this long. Why is it becoming this long and complicated? Because ultimately, if that was the question, you should have differentiated it. You should have found out the value of R. You should have substituted the value of R and ultimately found out the value of A. But that is not the question, I believe. The question is different. So yes, and taking down the 4 pi r square over here, what would you get? You would get something like 2 pi A into r square by 4 pi r square, and this would be, okay, I'm writing down the terms separately for this guy over here, where okay, let me write down separately, okay, and I'm taking down this thing guy, this guy separately, where r 2 pi A into A square plus of Q, okay, this is negative, this is positive, okay, let me do a thing, divided by 4 pi r square epsilon naught divided by 4 pi r square. All right. Now this term is like cancelled out. A is constant. Do remember A is constant. So no worries. So this would be like 1 by 2. And I'm not going to cancel. Okay. Should be. I don't think there's a necessity of cancelling out anything. Here also there will be an epsilon naught. Here also there will be an epsilon naught. Okay. But I can forget the denominator. I'll give you the reason why. Because I'm going to ultimately differentiate it. Okay, one thing that we need to be cautious about is this epsilon naught, and one thing we need to be cautious about, this is a constant term. If you notice, this is a constant term. The next thing we have to do is dE by dr is equal to 0. What is dE by dr? dE by dr, first term, this is going to be 0. Okay, 2 pi a r square divided by 4 pi r square into epsilon naught. This is going to be 0 since only 2 pi a divided by 4 pi epsilon naught is left, which is a constant. Next thing, what do we have? We have something like negative 2 pi a square a square divided by, so in both you have r square common, if you notice it. Okay, let's do it in the fastest possible way. So here also you have r square common, here also you have r square common, and rest is a constant term. If I just write down the rest of the term, this would look something like this. It would look something like q minus of 2 pi a divided by 4 pi epsilon naught. Why am I not taking it down? I'll tell you, because ultimately, okay, answer should have been a is equal to q by 2 pi. Anyway, if you differentiate this, this is going to be minus 1 by r cube, and there would be also 2 on the top. Okay, now if you equate this to 0, find out the value of a. So what is that only one term that we need to work around, guys? Only that thing written in the square bracket. If you differentiate this, you get this, but all you are worried about is just and just, which one? Just and just this thing over here. All right. And yes, of course, if you understood it, if I'm going to equate this to, okay, let me write it down. Let me write it down. We don't have space, I guess. This is little I'm going to carry this entire thing to a blank screen. So do remember this, dE by dr is equal to 0 plus of q minus 2 pi a divided by 4 pi epsilon naught. dE by dr is equal to, one was 0, the first term that we add was a constant term, and then what did we have? We had something like q minus 2 pi a divided by 4 pi epsilon naught into minus 2 by r cube, which is equal to 0 which means these terms are not relevant for our calculation. Okay, if I write it down further, like just these two, because anyway this is 0, what would you get? You would get something like q minus, you can directly, if you understood it, you can directly say q is equal to a is equal to q by 2 pi a. So there should be an a square as well. Okay, there should be a square. I think we missed out the a square over here. Okay, so the dimensional consistency is not there. This should be q minus of a square. The problem looks complicated. It's not really that complicated, trust me. So yeah, let me write it down again. Let me do a thing. Okay, this also not possible. This also not possible. This also not possible. I need a new page. All right. All right. I'll take you through the process, guys. So what did we have? We had d by dr is equal to 0 is equal to how much? Something 0 plus. Okay. Q minus 2 pi a square divided by 4 pi epsilon naught. After differentiating we are speaking, so this would be how much? Minus 2 divided by r cube. This should be 0. You know, these terms can be directly be cancelled out when you are equating them to 0. You're equating them to 0, so this you can cancel out, this you can cancel out. What is left over? This term should be 0. Anyway, this will go off, okay, while you're calculating them. So q minus 2 pi a is equal to 2 pi a square is equal to 0. Q minus 2 pi a square. Do we have anything else? No, I don't think. The rest is all, you know, gone in that 0 thing when you're multiplying it with the 0, and you would get a to be how much? A to b, so you'll be getting q is equal to 2 pi a square. That way a would be q by 2 pi a square. Alright, our guess was at least correct. There should have been a 2, but I think we missed out a small thing. If you had corrected this, you will get the answer. Simple, guys. Let me explain you what has been done in this question, what has to be changed in this question. So it would have been rho is equal to a by r. Okay, we missed out this thing. We wrote it as rho is equal to a into r, and then we calculated the charge enclosed by simply multiplying rho with like elemental volume, and found out the charge enclosed in it. Two charges will be enclosed in it. One is the charge q placed at the center of the sphere, and there is this charge that is enclosed between these points. Okay, and post that we said that the question says that your electric field is constant throughout. That is only possible like if you calculate the electric field and differentiate it with respect to r, and it comes out to be 0. Okay, first of all, to calculate electric field, we made use of Gauss law. Okay, one of you had a question, what is this Gauss law? Gauss law is nothing which says that electric flux, which is nothing but electric field into area, is equal to q by epsilon naught. Okay, q enclosed by epsilon. Q enclosed, we just said these both of the things. Okay, and then post that what did we do? For r, we calculated the charge density. Okay, sorry, the charge enclosed. The charge enclosed is going to be q plus of rho into 4 pi r square into dr. Okay, that is going to be q plus of a by r into 4 pi r square dr. Alright, and rr would get cancelled out. So this would be like 4 pi r dr. That is q total would be how much? Q plus of 4 pi q plus of 4 pi a r dr, which you integrated, you will get to be like r square by 2. So r square by 2, you would have a 2 pi on the numerator, and on the denominator 2 would get cancelled. Basically r dr is going to be r square by 2. I cancelled out this 2 and this 2 and I had like a 2. Okay, and this has to be integrated from a to r. Okay, alright, that said, we said that it's going to be q plus of 2 pi a r square minus a square, since the limits were r to a. Okay. A to r, since the limits were a to r. Alright guys, a to r. Okay, and there was a box over here, there is nothing else. So we just calculated that and moved on and found out what is the total charge enclosed in this question. Total charge enclosed in this question. So then in this given problem, okay, anyway, flux we wrote it to be E into 4 pi r square, since this surface area is going to be 4 pi r square. Okay, that is the area from where the flux is exiting. Alright, E into 4 pi r square is equal to Q enclosed by epsilon naught, which is going to be Q plus of 2 pi a r square minus a square divided by epsilon naught. Then I said that you just differentiate, you find out electric field alone and differentiate it with respect to r, you'll get the answer. That is what we did. We said 4 pi r square into E is equal to 2 pi r square minus a square plus Q divided by epsilon naught, and I took this 4 pi r square on the denominator. Then we found out that one of the term comes out to be 2 pi a divided by 4 pi epsilon, but nowhere it is said that a is varying with r. A itself is a constant and the constant's value is being asked. So we notice this term, we differentiated it with respect to r, because electric field has to be differentiated with respect to r. We got it to be 0 plus of Q minus 2 pi a square divided by 4 pi epsilon into minus 2 by r cube is equal to 0. If you carefully notice this term, you will get a to be Q by 2 pi a square. Okay, from this you will be getting a to be Q by 2 pi a square. That's the answer should have been a. Alright, that's it guys. Okay, it cannot be pi a square, but there were like two options which could have been confusing, but anyway, you could have eliminated B and C in the beginning. Alright, easy, simple. Alright, let's get into the rest of the problems from tomorrow onwards, but before that, let me give you some important information, guys. Today at 9:30, that is the next half an hour, we will be having we have more questions to go on. Don't worry, we have like a lot of questions for tomorrow. Today in half an hour, that is going to be, that is at 9:30 p.m. there is going to be an Ask Us Anything session from our JEE English team, where you can come live and ask us anything. We will be able to equip you with the strategies and the energy that you need for your JEE Mains and JEE Advanced preparation. Be it you're a parent, you can attend it. Be it you're a student, you can attend it. Be it you're an aspirant planning to pursue a JEE Mains and JEE Advanced dream, you can come and ask us anything. Tonight, 4 of us will be present on this session. So make sure you're attending it and you're enjoying this session, guys. You're enjoying the session, you're attending it, and make sure you're not missing it out. And students, units, dimensions and measurements, A to Z of units, dimensions and measurements has been completed. 2021 aspirants, do not ignore this concept or this chapter. In this 4 session plus 1 model problem session, this is the number of sessions that has been conducted on Unacademy Learning App by me. You can cover those things. 2020 aspirants, a very important thing for you. You know that 2021 aspirants often ignore this topic. Don't do that. It's a very important topic, because typically you get 1 question every year, and not only that, it will take less time during your preparation, during your exam, and it's also that part of that pie which has that easy part of your question. So definitely do complete this part of your syllabus, guys. It's only 4 plus 1. You can complete it on 1 weekend. That is how much time it is going to take. And do not miss out today's 9:30 p.m. AMA session. And that being said, students, Unacademy Combat is going to happen again on 6th of December. Be sure to attend it to win lots of rewards and prizes. This includes amazing prizes from our team, like MacBook Air, iPad, earpods, and also more and more hundreds of Amazon voucher worth thousands of rupees. So do attend this Unacademy Combat. It's going to be a gamified competitive event, also an amazing experience for you. It's going to happen again on 6th of December. Enroll today with Murli live code. And students, share this video, like this video, so that you should know where you would be going wrong in your exam. If at all the question was wrong, you should be able to identify it. You should learn those tricks and tips. How did I say that question was going wrong? It's a very simple way. I understood that beyond a point, it should be R should be a dependent of A, then we need to substitute R and finally get that answer in terms of R. But R is not possible that you get it as a constant. Anyway, R is varying. So A into R couldn't have been the row. It should have been A by R. Anyway, I hope you understood that concept. Even kept the charge inside, you should be adding that charge in your charge enclosed. Alright students, do share this video, do like this video, do not forget to share it on your social media like WhatsApp, Telegram, etc. so that someone in need may get access to this lectures and they will be able to learn about it. Work hard and smart to achieve your success, acquire knowledge and keep sharing it. And students, let me tell you something, if you are not yet on our Telegram channel, do quickly get onto our Telegram channel. So what is this Telegram channel and what is this Telegram? Telegram is an app where we have created like our own there are like many it's like a chat app, but you can download it from Google Play Store and App Store, and then post that you can click on to this link which is available in the description box below. So first of all, you need to download this app. You'll find this symbol, you need to download it and then click on to this link, and you can also just type in JEE_English and you will be able to find us on Telegram channel, our Telegram channel, where you would get live before time updates on every session that is being conducted by our JEE English team. Hi Cheshwara, hi. By our JEE English team, be it on YouTube or an Unacademy learning app. Alright students, good evening Cheshwara. Do check out this lecture, complete it, try to get that question on your own, taking it A by R, do not miss it out. So yes, if you do not have an Unacademy learning app yet, just to download it from your Google Play Store and App Store, type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. Click on this install button once you click on to this link, because you would get live before time updates on every class that is conducted by me on Unacademy learning app, guys. So those special classes I keep conducting, A to Z classes. Once you start following me, you will be able to follow my A to Z classes on Unacademy learning app as special classes. Not only that, you will be able to also get live updates from the educators that you follow, and students, more importantly, you can attend free quizzes every week from our JEE English team, and also you can attend Unacademy Combat, and you can attend classes from anywhere, be it special classes, and if you have Plus subscription, you can also attend test series from anywhere. So yes, there are like some major reasons that you want to download an Unacademy learning app. And if you're looking for a complete package, the best in class program for your JEE Mains and JEE Advanced preparation, it is going to be, guys, Unacademy subscription. Why do I say that Unacademy subscription is going to be the best thing for your JEE Mains and JEE Advanced preparation? Because it's a complete package for your JEE Mains and JEE Advanced preparation. What do I mean by complete package? You will get best educators across the nation on the best of the kind program, on the best of the kind platform. What do I mean by this? Best of the kind program and best of the kind, platform. As you understand that we have all the best educators aggregated on one platform, that is going to be an Unacademy subscription. But apart from that, we have the best program. It's going to be a structured, systematic program where you will be able to learn everything around your JEE Mains and JEE Advanced. Every single topic, every single program is going to be a structured program. That way you will be able to maintain the completeness. In the structured program, every 4 session will be a doubt clearing session. There will be quizzes and mega quizzes associated with each and every program. Moreover, we have dedicated droppers batch and micro courses on Unacademy subscription platform, and this platform would also be very attractive and interactive, where you'll be able to interact with the lecture. Along with that, your learning will be fun, since you'll have polls, leaderboards, so many things on Unacademy subscription platform. All you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal. With this, you'll be preparing for both JEE Mains and JEE Advanced, and hit on this get subscription button. It's one subscription, one unlimited access throughout that period. You can attend as many programs as you want. You can attend programs on optics, you can attend programs on electromagnetism, you can attend maths based courses, you can attend droppers batch, etc. And guys, this all comes at a price of less than 2,100 per month. 2,100 per month, less than 70 rupees a day is what you have to pay for this amazing Unacademy subscription. And be sure to apply Murli Live code to avail the best discount on your subscription purchase. So if you want the best discount on your subscription purchase, you may want to apply Murli Live code. And students, that 24-month program is typically meant for 8th class, 9th class and 11th class students. But if you are looking for some convenient payment options where you have to split your payments into multiple parts and do not want to go through the burden of paying all the fee at once, it's going to be pay in parts option, which is our in-house feature. And we also have no cost EMI, where you do not have to pay any interest on your easy monthly installment purchases. Yes, these are two interesting payment options which which you want to check out while purchasing Unacademy subscription. And guys, we do also have, you know, like other payment modes like debit card, credit card, and UPI for your convenience. And students, let me tell you, we also have 12-month program dedicated to droppers and long-term students. What you get on this is not just, you know, like typical programs, but if you have been disrupted by this pandemic, this is the program to go for, because we have droppers, batch, micro courses, etc. on Unacademy subscription platform. More importantly, national level test series and classes from the best educators across the nation. And this all comes at a price of less than 2,900, only at a price of 2,888 after you apply Murli live code. Alright guys, that being said, this is plus, but there is also something more known as Iconic, where you can get in personal touch with, you know, lecturers, teachers who are IITians and who have been going through this journey, who are IITians and who have been going through this journey of cracking JEE Mains and JEE Advanced. They will be able to give you, you know, that personal guidance to you for your JEE Mains and JEE Advanced preparation. You can get their, you know, like personal coaching, you can get their expert guidelines and workshops on Iconic subscription. And students, this all comes at a price of, you know, 58,500 if you go for a 12-month subscription. If you go for a 24-month subscription, it's going to cost you only 90,000 after you apply Murli live code. So be sure to apply Murli live code on any of your Unacademy subscription purchases, and to avail any best discount on any of your you know, Unacademy subscription purchases, be it Plus, Iconic, or any of the programs. And guys, let me tell you something interesting. Our team, JEE English team, is on Iconic subscription. We can take your JEE preparation to the next level, that too exclusive and completely English. You can get in personal touch with us and get our personal coaching. You can get our JEE workshops, expert guidelines, study planner, and frequent test analysis from us. Take care, stay safe, bye bye. See you in the next PYQ session and gravitation session. Stay tuned to the lecture. Do not forget to like this video and share this video. And today at 9:30 p.m. see you in the class.